right, welcome back to another Remote Monday. There are going to be a lot of vocabulary here. I'm going to go over it very simply. We're going to make a chart and everything in class, but notes are notes. We need an introduction. We need some place to start. We need some kind of base to build on. So, for example, something that we're going to be talking about is equivalent expressions. And equivalent expressions is like saying that 4k plus 8k is equal to 12k. And we know that's true. We can combine 4k and 8k to get 12k. Then we also have the additive identity. And this is with the idea that the sum of any number and 0 is that number. So for instance, the sum of 0 plus 5 is that number 5, or the sum of 0 plus 12 is that number 12, so on and so forth. So there are some properties of both equality, like equivalent expressions, and additive properties that we are going to talk about. So, properties of equality. And you're going to have the reflexive property. We'll have the symmetric, transitive, and the substitution. So those are our properties that we are going to be talking about. So the reflexive property is that any quantity is equal to itself. So an example of that would be something like A is equal to A, B is equal to B, 5 is equal to 5, 6 is equal to 6, 4 plus 7 is equal to 4 plus 7, so on and so forth. And you can use any symbol there that you want. All right, so the next one, the symmetric property, is if one quantity is equal to a second, then the second equals the first. So that would be like saying if A is equal to B, then B is equal to A. Or if 2 plus 6 is equal to 8, then 8 is equal to 2 plus 6, so on and so forth. So that is the symmetric property. The next one is the transitive property, which is if one quantity equals a second, and the second is equal to the third, then the third is equal to the first. So for example, if A is equal to B and B is equal to C, then C is equal to A. And you can use that for any kind of number expression. We could take the reflexive property and say if A is equal to A plus B is equal to B plus C, and B plus C is equal to D, then A plus B is equal to D, so on and so forth. And I know that's a lot, and we are going to go through them and give some examples. We're just trying to get some vocab done first. So finally we have the substitution property, And a quantity can be substituted. For its equal in any expression. So for example, if A is equal to B, then you can replace A with B. So it's what we've been doing when solving expressions. So then we have those additive properties. So we have the additive identity, which is what we just talked about. We have the additive inverse. Oops. Erase that line because it was way too big for what we need. And we did talk about the additive identity. If you would like to put it in the chart, you can go see the beginning of the notes when I gave you that definition. So the additive inverse is a number and its opposite are additive inverses of each other. So a number and its opposite are the inverses. I'm just going to write the number and its opposite because we're referring to this definition then. Which just means that A plus negative A, so it's positive and it's negative, is equal to 0 in any case. There are some special properties as well. There's the multiplicative identity, there's the multiplicative property of 0, and the multiplicative inverse or reciprocal, which we've talked about before. So we are going to go through those multiplication properties. All right, so the first one is the multiplication identity. We have the multiplicative property of 0. And we have the multiplication inverse. This is also known as the reciprocal. I'm pretty sure we've mentioned that in here, maybe not. I know I've mentioned it in geometry. So the multiplicative identity is that for any number A, the product of A and 1 over A. For any number A, the product of A is 1. A and 1 is A. So that just means that if I take any number and multiply it by 1, it's going to be that number. So 2 times 1 is 2, 14 times 1 is 14, so on and so forth. And I can write that the opposite way, A times 1. It doesn't matter which way, it's still going to give me that value of whatever I multiply 1 by. So then the multiplicative property of 0 is for any product A and 0 is 0. So 0 times A is 0. A times 0 is 0. No matter what I'm multiplying my number by, if I'm multiplying by 0, it's 0. So then finally, the multiplicative inverse is where A over B and B does not equal 0. Remember, that does not equal 0. There is one number that would produce the product of 1. So in other words, what it's saying is that if I have A over B and I'm multiplying it by B over A, which this then is the reciprocal, I would get the answer of 1 because my B's would essentially cancel and then my A's cancel as well, giving me a product of 1. So I'm going to give you a list of steps and then you're just going to name what each step is similar to. So for this first example, if I give you the problem of 7, 4 minus 3 minus 1 plus 5 times 1 over 5, and then I do 7, 1 minus 1 plus 5 times 1 over 5. Looking at that step, what I did was I combined together these, so I used substitution essentially, or I used just plain subtraction. It is substitution because I know 4 minus 3 is 1. They're the same thing. And I'm going to move that down there. Okay, so I have substitution. Next, I am going to have 7 minus 1 plus 5 times 1 over 5. And there, I multiply these together, so I use the multiplicative identity. And I'm abbreviating multiplying or multiplicative by MULT, so that way it's not such a long word. Next, I am doing 7 minus 1 plus 1 because I have to do this next according to order of operations. I'm still using my order of operations here, so I did parentheses, multiplication from left to right. The 7 times 1 came first, so I'll do that first. And 5 times 1 over 5 is using the inverse. It would technically be the multiplicative inverse. But I'm essentially using the inverse because 5 over 1 is how I could write my 5. And I'm taking the reciprocal of it and multiplying. Next I have 6 plus 1, and I'm taking 7 minus 1, which would be another example of substitution. And then 6 plus 1 is 7. Again, that is substitution. If you wrote adding or subtracting in those particular cases where it's substitution like that, I would probably accept it because it is a little confusing as to why it's substitution. All right, so there's an example of using some of those vocabulary words from the tables that we have created. The next thing that we're going to talk about, we have some more vocabulary terms. I think there's 2 more and then 1 more example, and then I'll give you 2 that you do by yourself. So we have what's called the commutative property. So it's an addition property. And abbreviate property is just PROP. So the commutative property is that if you add or multiply, the order doesn't matter if you change it. So So the order when adding or multiplying doesn't matter. The answer is still the same. So for example, if I did A plus B, that is the same thing as B plus A. Or if I plug in numbers, 5 plus 4 is the same thing as 4 plus 5. And that goes for multiplication too. So B times A is the same thing as A times B. Finally, we have what is called the associative property. And that just means the way you group 3 or more numbers. The way you group 3 plus numbers when adding or multiplying doesn't change the sum or product. So again, it doesn't change the answer. So an example of this is if I had A plus B plus C, I could group these two together, and it would be the same thing as doing A plus B plus C and grouping those two together, as long as there's still a plus sign there. Or if I was using numbers, I could do 3 plus 5 plus 7, and 3 and 5 in parentheses. Or I could do 3 plus and then 5 and 7 in the parentheses. And then the same thing goes with multiplication. If I have A times B times C, I could do A and B together. And then if I have A, B, C, I could do those two together as well. Again, it's not going to change the answer. So a way that we could see this is if I had this list of numbers, and then we're going to explain how we can do this. So if I had 975 and 850, 5325 and 2250. If I did 975 plus 5350 plus 1850 plus 2250. The way I just did that is I just moved things around, which shows me using the cumulative property. And then if I decide that I want 975 and 5350 together, and I'm going to do those together, and 1850 and 2250, group those together, that would be the associative property. So then I can go ahead and solve that. It would be 63 and 41, and that would be substitution because I'm solving. I'm taking out those other two numbers and replacing it with 1. And then finally it would be 104, and again that would be substitution. So that's an example of how that works. So I am going to give you 2 problems to try. So for the first one, I'm going to write out a list, and then you're just going to tell me what belongs to each of those. So if I have 7 times 1 over 7 plus 6/15 divided by 3 minus 5. I'm going to go through the steps. So that changes to 7 times 1 over 7 plus 6, 5 minus 5. You're going to tell me what goes there. And then 7 times 1 over 7 plus 6 times 0. Tell me what happened there. And you can just list them in a comma-separated list. That would be fine. Oops. I'm sorry. 1 plus 6 times 0. Tell me what happens there. You can tell me what happens in each of those. So go ahead, solve that one. Put in your answer. You can put it in a comma separated list, or you can put it with enters. I don't think that'll submit the problem if you hit the enter button or the return button. All right, so that's your first one. Your next one is going to be, let's see here, 5 times 7 times 4 times 2. And then I'm going to change it to 5 times 2 times 7 times 4. Tell me what happened there. 5 times 2, 7 times 4. What happens there? 10 and 28. And then 280. All right, so that's your second one. And then you'll have to answer the question as to how you feel, and you're all set.